Some planets are so scary they don't feel real, but the data is real. And I don't mean scary, like aliens jumping out at you. I mean scary, like physics doing something crazy your brain refuses to picture properly. Let's say a planet so dark it seems to eat light itself. Another planet where a world where rock behaves like an ocean because it's too hot to be solid. A planet that might look like an actual eyeball from orbit, ice everywhere, with one melted spot staring straight at its star. A rocky world that could be a permanent lava ocean. And a gas giant where the wind is so violent that it turns into sharp glass, ready to pierce through everything. I'm not even joking, the storm on one of these is basically a weapon. And if this sounds like a sci-fi writer got carried away, yeah, same. But here's the thing, I'm not just making up things here. These are real, confirmed, most creepiest planets in the universe discovered so far. Each one has at least one detail that makes you go, wait, what? Today, you're going to take a look at 5 creepiest planets that will honestly blow your mind, and why each one is unsettling in a very different way. Let's begin. LHS 1140b is a super-Earth orbiting a red dwarf sitting in the star's habitable zone. And it's one of those planets where habitable doesn't automatically mean friendly. Here's the visual people can't shake. If a planet is tidally locked, one side always faces the star. Same face, forever. No sunrise, no sunset, just a sun that hangs in the same part of the sky like it's glued there. And if the planet has the right kind of atmosphere and heat transport, that setup can create a bullseye pattern. Cold, frozen regions, possibly huge ice sheets, surrounding a warmer area near the point facing the star. A single melted eye in an otherwise frozen world. Now, to be clear, we do not have a photo of a literal eyeball planet. What we have is the orbit, the size, the mass, and the physics that says, if it's locked and it holds air, this is one plausible outcome. LHS 1140b is especially interesting because it's not just a we think it exists planet. It's a transiting world with measured properties, roughly Earth plus in size and several Earth masses, orbiting every approx 24.7 days at around 0.095 astronomical units. This is where it gets weird, because the creepy part isn't monsters, it's the calm. Imagine a sky that never changes. Imagine weather patterns that might be locked into place for years. Imagine living in a world where going west isn't just a direction. It's literally walking toward permanent night. And it matters because LHS 1140b sits in a range where scientists can realistically chase an atmosphere signature in the future, if it has one. If a planet like this can hold on to air around a red dwarf and keep liquid water stable in any region, it changes what we mean by habitable zone. Hold that thought, because the next planet is creepy for the opposite reason. Tres 2b is famous for one thing. It's ridiculously dark. Not dark like the night sky, dark like if you placed it next to space, you might not notice a difference. Scientists measured its reflectivity and found an extremely low geometric albedo, less than 1% in models, and in best fit cases, effectively near zero. So what it might actually be like. Picture Jupiter as a bright marble, cloud bands reflecting sunlight. Now picture this planet as black velvet, not because it's painted, but because its atmosphere likely lacks bright reflective clouds. And because at high temperatures, the chemistry can destroy the kinds of condensates that would normally scatter light back at you. And this isn't mythology. This was pulled out of Kepler photometry, measuring tiny changes in light as the planet moves through phases. They detected the faintest visible light signal, and the conclusion was basically, this thing does not reflect much at all. The thought that sticks. If you were near it, it wouldn't look like a planet. It would look like absence, like a hole punched into the starfield. And that's a perfect setup for the next one. Because if Tres 2b is creepy because it's blank, WASP 76b is creepy because it's busy, violently busy. WASP 76b is an ultra-hot gas giant, so close to its star that the day side is extreme, and the temperature contrast between regions can drive insane atmospheric flows. And then we get to the sentence that sounds fake, until you realize it comes from actual atmospheric detection. On this planet, iron can exist as vapor on the hot side, get transported by winds, then condense on the cooler side, a process that led researchers to describe it as iron rain. Why we think that's happening? The evidence comes from high-resolution spectroscopy, basically reading the planet's atmospheric fingerprint as it transits. A 2020 Nature paper reported an asymmetric signature tied to neutral iron, consistent with iron being present in one limb and missing in the other in a way that fits condensation as air moves across the planet. This is chemistry happening at planetary scale, vaporizing metal, transporting it, dropping it out over and over. And if that one feels extreme, the next planet is the one people describe in a way that makes you instinctively flinch. Just a quick note. If you like space documentaries that provide you with genuine information, subscribe to the channel and like this video if you are enjoying it so far. HD 189-733b is a hot Jupiter with an atmosphere that's been studied a lot because it's relatively bright and close in astronomical terms. It's often shown as blue in visuals, but that color is based on how its atmosphere scatters light, not because it has oceans like Earth, and the conditions are nothing like Earth. This is the one people describe as glass rain sideways. Here's what that actually means in a more realistic way. Observations and models suggest the atmosphere can contain silicate particles, the kind of material that can form glass, and the winds are so fast that any particle-laden precipitation wouldn't fall gently downward the way rain does here. NASA's Hubble write-up describes the winds as howling at about 4,500 miles per hour and mentions possible sideways glass rain. So, no, it's not like windows shattering and raining down. It's more like tiny abrasive particles in a high-speed flow. Imagine standing in a storm where the air itself is moving faster than most jets. You wouldn't feel like you're in weather, you'd feel like you're inside a machine. And it forces a question that sticks. At what point does weather stop being weather and become a surface-level shredder? Now, for the last planet, I want the vibe to shift again, back to a rocky world, something that should be cooked clean and yet might still have something like air. 55 Cancri E is a super-Earth so close to its star that the surface is expected to be scorching, with the possibility of molten rock and lava-like conditions. If any planet had the right to be dead and silent, it's this one. And yet, this planet is famous for a reason that's actually kind of huge. Researchers using NASA's James Webb Space Telescope reported evidence that suggests it may have an atmosphere, possibly containing gases like CO or CO2, based on how heat is distributed and features in the infrared data. That's wild. Because worlds this close to their stars get blasted by radiation, you'd expect atmospheres to be stripped away. So if 55 Cancri E can maintain or replenish an atmosphere, possibly through outgassing from a magma ocean, it hints that rocky planets are not always as cleaned out as we assume. Because it's a reminder that rocky planet doesn't automatically mean Earth-like. A rocky planet can be a glowing ember. A rocky planet can be a world where the ground is moving in slow motion because it's not ground anymore. And the best part? We're not done learning what this planet even is. Recent work still debates how to interpret some signals and variability. Here's the mature truth that makes all of this feel more unsettling, not less. Most of what you see in videos, those gorgeous renders, the glowing lava, the black spheres, is reconstruction. It's art guided by math, but the measurements and constraints behind these images are 100% real. Spectra, transits, radial velocity, those aren't just fake, they limit what's possible. They tell us a planet's size, its orbit, its temperature range, sometimes hints of what's in the air. TRES 2b might not be a perfect black ball, it might have subtle glow from heat. LHS 1140b might not be an eyeball, it might be a thick atmosphere world that spreads heat better than we expect. 55 Cancri E might have a patchy, shifting atmosphere we're only beginning to detect. And that's the point. We're discovering how weird normal can be. So, I want to ask you something. Which one is the creepiest to you? The violent ones or the quiet ones like LHS 1140b? Like this video if you enjoyed, and subscribe to the channel if you want more real science with the actual mystery left intact.